Hi there and welcome to another of the DTA screencasts, and in this session here we're going to be talking about how we analyze all the information we can get from our understanding of biomechanics. So it's about the application of this knowledge, and one of the things we need to look at is how modern technology is able to be used to analyze those performances. So we've understood about levers, we've understood about center of mass and movement. And now what we need to be able to do is look at the three main different ways that we can analyze these performances. So there is a very good video, and I won't go through it now, but what I'd like you to do is if you just type in Ronaldo and limb kinematics or Ronaldo and analysis of performance, there's a 28-minute video which is really worth watching. It's very well done, and it looks at the limb kinematics. In other words, how the limbs move and how is it that Ronaldo is as very good as he is. I'll put this PowerPoint on our group page, and then you can access the link from there if you can't find it yourself. But in essence, what it was talking about is the movement and relation to time and space. Some fantastic little analysis of a sprinter going through cones, and because this is moving to the left and right, Ronaldo is actually faster than a world-class sprinter because it's about his body makeup. So do have a look at that. It's very, very important. The other thing it does is it gives you a 3D perspective as opposed to just data on a screen, so you can work out a lot more information from that. And you can look at the efficiency of particular limbs. All right, so what are the advantages and disadvantages of using quite extensive technology? So what are the types of things you've got to think about is how accurate do you think it would be? So once you've had a look at the video, jot down what you think about the accuracy. What do you think about reliability, validity, cost, and the quality of the data provided and how suitable it was to everybody? Now we can look at each one of those individually. So accuracy, that's quite clear, is the information given a true reflection of what's actually occurred? But reliability, this is where we're talking about the extent of the experiment, testing or being able to repeat the same activity. Would we get roughly the same result? So let me explain. Let's say we do the Cooper run. So we set the the Illinois agility test. Let's say we start at A and we get the person to run to C, then back, then D, then back, then round B, and then finish here. Okay, but the next time I do it, I get them to run sort of to C, then D, then B, then A. All right, now as much as they're both measuring agility, you could argue, because that's the ability to change direction, is the test reliable? You could easily say, well, no, it's not, because it wasn't exactly the same. So it's very much about making sure that the test is exactly the same each time we go through. So this man has to run from A to C, round to D, round to B, and then back again. That's it. Now, there are other versions of the test, but I'm just saying that it has to be exactly the same. How can we make it more reliable? Think about the person and what they've done. Okay, right, yeah, so good. So we could get them to warm up exactly the same as they did last time. Other things we could do is do it at the same time of day. We could also get them to wear exactly the same kit and make sure they have the same breakfast. And the further we go into making it more reliable, then what we're doing is ensuring that we have a reliable test. It's really important. When we're talking about tenths of a second difference between somebody winning and losing, we need to nail down every possible variable. All right, so that's reliability. Now, validity, this is how well the test measures what it actually claims to test. So, you know, when you've been told when you're doing GCSEs or in Key Stage 3, right, sprint from there to there and we'll measure how fast you are. Well, is that actually how fast you are? Or is it a measure of your acceleration? So your ability to move from 0 to whatever speed you can get up to, let's say 17 kilometers an hour. So you could argue that that test that has a start and then you sprint for 100 meters is actually a test of acceleration and speed. But a more accurate or a more valid test of speed would be if we're running through speed gates. So you can see the start point is down here. They've already accelerated up to their potentially optimum velocity. And then what we're doing is moving forwards through the gates, and then this will be a measure of their speed. All right. So force plates. Here's another interesting one here. So force plates are used for different elements of biomechanical assessment. You think about basketball, fantastic one for that. High jumpers, lots of different variations. Trying to measure what? What's it trying to measure? So if you click on this, and those that are in the group, then you can have a look at the video about force plates. So what they're doing is they're measuring the force that we can exert through our legs. So the longer we can stay off the plate implies the higher that we've jumped. Now, these can support things like gait, analysis, balance, posture for running, rehabilitation and physical therapy, as well as acceleration work and power output. I recently had one of these tests after a knee injury, and they were checking to see how much force was coming down as I landed back on the floor through each one of my feet. And I'm still at a stage where one foot is taking more of the force because the other one is trying to compensate for it. So that's my own personal experience of using force plates. So again, let's think about the advantages and disadvantages of this. So is it an accurate score? And you could argue yes. Now we've talked about reliability, so we need to make sure the test is reliable as possible. So validity, what's it actually trying to test? So it's force that you're able to exert through your legs, your glutes, gastrocnemius. Fine. But how much do these cost? They're quite expensive actually. So therefore, is it going to be suitable for everybody? Is everyone going to be able to access this information? Probably not. And then let's look at this component here, the suitability to everybody. Is it going to be appropriate for somebody to go onto a force plate? Is it appropriate for somebody to... Is it appropriate for somebody to go through the kinematic analysis that Ronaldo did? It's very, very expensive, isn't it? So, for that reason, we've got to try and think about how suitable it would be for everybody. Or is this just really for elite athletes? Right, and then our last component here, wind tunnel. There's loads. Again, there's a really good video on this for the group. But do type in wind tunnels and sport, and you'll find loads of different examples. But there's loads of ways that the wind tunnels get used. It's trying to look at resistance, isn't it? The resistance of the body as it moves through the air. And you can see obviously here this one's being used for downhill skiing. You can improve your flow by changing the shape of the helmet. There's some really cracking examples of this guy here. So do click on that link down there. And look at the suit that's been made up to try and reduce the amount of resistance. That was all designed in a wind tunnel. Do have a look at the video. It's quite an interesting one. But again, think about this. Accuracy. How accurate is the results from the wind tunnel? Reliability. Was that taken into account? How valid is it? So what's it trying to measure, and then how valid is it? Costings. Very, very interesting, is it? I wonder how much it would be for a wind tunnel for an hour session. Quality of the data, I imagine, is very, very high. But then, is it going to be suitable for everybody? You say again, probably not. So what you need to be able to do then is state how each one of these different elements work. So limb, kinematic, force plate, and then wind tunnel. What are the advantages? And then what are the disadvantages? All right, so that's the end of the screencast. As I said, do go on to the group page and click on each one of the links. If not, you can find your own versions. All right, thanks very much.